Here we are back in the lab today. I mean, we're in the lab every day. We just don't always stream it. Maybe we should. Tell us in the comments. There's the star of the show hanging out on the rack. Hanging out on the rack even, if you couldn't hear over the truck outside. I'm still finding traces of this super lube all over the place from before. I definitely used way too much. I'm sure there were people just like screaming at the monitor as I was gooping it on the gears. I was worried about it getting in all the crevices. I think maybe next time I will try applying a smaller amount using the end of something pointy, like a toothpick or a brush or something. Anyway, things are weird. Just in general, you know, the condition of being a human. But in case you ever feel like being a human is weird, you could try using some software. This camera needs a card. But speaking of software, yeah, humans are weird, but CAD software is also pretty strange. It's nice being able to reach the camera control. I'm so looking forward to having a bot that can move the camera around. I still have this exposure set kind of up. So welcome back to the stream. If you're new here, this is part of an ongoing project to make a little wire-driven, well, nylon cord-driven robot with a camera and a gimbal at the end that's going to be part of a way to interactively play with my cat over the internet. It's one of a few things we've been working on. I've also been jonesing to assemble the latest BoldPort kit, and there's some stuff that I've been excited to take apart and hack on. So that's all coming up, but this stream, I really wanted to just do some CAD work at first just that I can get the printers busy again. So there's a lot of 3D printed stuff in this project, which is nice because it's a design process that I like and that I'm used to and that I have the equipment for. It does involve waiting for the machines, but if you can time it right, you can be doing other things on other projects while the machines work on and squirting out these plastic parts. Maybe we'll even let the machine handle the focus. Oh man, are we servo AF today? So a lot of these parts are for the robot flyer. This is still obviously in need of some assembly, but most of the parts are actually here. This is the sensor, saucer, and then on top some navigation lights and the mount for the nylon cords that pull the robot around, and the orifice that the control wires go through. So that'll actually be where the power, Ethernet, and video come out. But then the load-bearing cords come out over here on these load-bearing arms. And so this blue piece is actually basically just a big cord guide and clamp that attaches the cords pretty firmly to these carbon fiber rods and also supports the pieces above and below. And then this piece below, it's mostly just there to hold all of these sensors. So it's got these 3 LiDAR distance sensors for sensing the ground, however far away it might be, and generally just knowing how high above the ground we are, even though there's some amount of occlusion happening and some amount of tilting going on. This will also have an IMU mounted down here abouts. And then it has this ring of 8 infrared sensors, which the goal here is, which I've been testing as well as I can, but it's still one of the more risky elements of this design, is that those sensors can detect when something is about to bump into the camera without actually constantly detecting the camera itself. So, this has been actually ready for us to do more assembly on for a while. I've just been trying to prioritize the stuff that's going to involve a ton of 3D printing, because I figure, you know, I want to get the design for the winch bot settled enough that I can just start printing off the parts for the 4 of these bots, you know, in mass. And while I'm doing that, there will be time to assemble the flyer and the individual winches. So mostly the next thing I want to do is get a design for the actual winch and validate it so that I can start making more of them. And so this was part of the original winch design. You can see it had a force sensor, a strain gauge like you'd find in a mechanical scale, and this is a rotary encoder measuring the actual progress of the cord going in and out of the winch. And so the idea was you'd need at least 3 of these to move the robot in 3 dimensions. I was going to use 4 of them because it also happens that the space the robot can move in is a polygon with a vertex at each of these, and I'd like it to move around in a roughly square space. So that's why I planned for 4 of these, but the design could be scaled from 3 of these to maybe several more than 4. They all just connect over Ethernet, and they have some local control, and then there's some central control. And so this is the most recent version of the winch. And we tested this on the previous stream, and actually I think it's looking pretty great. So the things that I'm planning on doing in CAD right now actually don't change any of this super significantly. I'm leaving these 2 blue pieces that we just printed, like, I mean, these are great. I think not finding any problems with those so far, and I don't really expect that anything that I will find is going to be worth reprinting them. We have this spool that works. This piece of the spool is a little warped because of just the print job. It did not stick down to my build plate. I have to print this on my bigger printer, which does not have a heated bed. So, Treehouse Man is asking, the winches are going to be on linear rails along the wall as well? No, the winches are actually, so they're going to be just stationary on the wall. So imagine there's a wall mount bracket that attaches here that I haven't designed yet, and imagine this loops through here, which I'll simulate by kind of holding it. Maybe I can't. Anyway. And then it goes up to the ceiling, and then there's another pulley at the ceiling, and then all of the cords meet at the robot. And so the actual geometry of that changes as the robot moves around. I want to roughly balance the tension on the cord so that the winches are all, well, I mean, the actual tension balance changes as the geometry changes. So, and there's still some open questions about the navigation, but basically it'll be using a slightly kind of under-constrained system to set the location of this thing by adjusting the distance between the pulleys at the ceiling and the winch in each of these 4 line segments. And so you'll have to be adjusting that so that you don't let any of those cords fall slack as you are moving this thing around, because otherwise you're prone to have knots and just generally not wind very well. You really want the tension on this to be roughly constant. Of course, it's going to change. Like, you can imagine the flyer is like up against one wall, then now 2 inches are holding pretty much the entire weight, and 2 inches aren't really holding any of it at all. You can imagine another extreme if it's like right in the corner, then 1 winch is doing most of the work, and then the other 3 don't have much. And so I'll have to set roughly, you know, sort of hard stop limits where the winch will say, okay, using this force sensor, if it gets out of this range, I'm just going to stop moving because I assume something's wrong. But then there's also going to be a narrower range where, you know, depending on the geometry, it can allow, you know, these ranges of forces, but that's actually going to be part of what limits how far the bot can move around in the room, because as it starts getting close to one wall, then the force sensors will notice, hey, these winches are about to get to their lower limit, you can't move anymore in that direction. And so that's actually part of what I think is going to help this thing set its bounds without an absolute positioning setup. So yeah, so this has been good so far. Some of the minor nitpicks which I want to fix in CAD like right now. The first one is I've been trying to reprint more of these spools. Not that I want to change the spool design really. This spool actually seems fine. Like, it's sturdy, it has a good attachment to the gear, it seems like the cord is not going to push it apart. But I've been wanting to make a change to the design to the inner core of this so that I can bury the knot that actually retains the cord, which isn't super significant, but it might help this wind a little more evenly if I could bury the knot and then push it all the way to the edge instead of just most of the way to the edge. Oh yeah, Nicholas says, I think a system sketch will be valuable. Yeah, actually, maybe we can just do that. And then Treehouse Man says, could you use empty filament spools? You know, it's really infuriating how much that almost works. I looked at that, but I didn't think it would really save me that much because the filament spools are a little larger than I want, and so I'd end up having to print a lot of the other parts to be correspondingly larger, so I'd end up using more plastic there. And then even if I wanted the spools to be that size anyway, I would need to print basically a little hub adapter that can grab onto the filament spool in a very structurally sound way. And so it didn't really seem like it would save that much material, and it's a lot more design flexibility to just CAD the spools that I actually wanted, so that's what I decided on. But that's a good question. It would have been nice if I could just use filament spools. That would have been poetic, even if it wasn't necessarily efficient. Treehouse Man says their thought is that it's a more stable spool. I don't know about that. Let's have a side-by-side comparison. I think my printed spools are stronger. So I have spools from several different brands here. Let's try to get a better camera angle. And then, don't really want to take that one apart, but I've got some others that didn't quite print right that we can use. Okay. Maybe it's time to have a visual comparison of these things. Oh man, this project has officially made my desk messy. Oh, there's like a trace amount of super lube on something. Alright, well, these are some spools. This is the previous spool, which was, well, not way too small, but a little small. This was my original spool, which was probably a good size. It was just too weak. And then I ended up making this one a little bit smaller for some reason. I think I was just trying that out. And then these are basically just copies of the one that I ended up going with. And this one is really strong. Like, this is not going anywhere. It's, I think, like 1.5 millimeters or so of solid plastic just at the bottom, and then it goes to regular infill. And this is the same, just both of these had warping problems, which is why I'm not actually using them. And so let's go through the filament spools. So all of these filament spools are significantly larger. So, you know, like if you imagine this is the size of the support machinery that's necessary for this spool, I don't think that would fit on my printer, the corresponding support enclosure for a spool like this. There are some smaller spools, but the smaller spools are often also kind of weird. Like this one has a cardboard core. This one would just tear apart, I think. I mean, this might work, but it wouldn't last super long. I think the plastic one would last longer. And I would still need to basically put some like spikes into this or something to drive the load into the core. Yeah, it would be weird. It'd be tough to do that in a way that seems actually better. And then all of the rest of these are way bigger than I want, but if we look at them anyway and how we wanted to drive, so these all have pretty, oops, there's that super lube. These all have pretty solid plastic hubs here. I mean, this is the nicest. With this one, you know, I have this area where I could basically print a coupler that goes from the motor shaft to a bunch of little teeth that fit into here and then drive it, and that would be nice. So I could see a different design working where you take a spool like this and make a flexible coupler, or even just, you know, a plastic coupler out of something like ABS, something that isn't super brittle at least, and fit the motor shaft somewhere around here. And then you'd still have to come up with a bearing for this. So that's still a problem. If you want to go with like nice steel bearings that are going to be quiet, then that part gets expensive. If you want something that is good enough and might be a little bit loud, you could just basically make a bushing by fitting like a plastic or cardboard tube in there. So you could make something. So the two constraints I have that make this a little bit more 3D print intensive in the end, the way I ended up designing it, I guess the constraints are really, I wanted it to be fairly quiet because I'm going to be around this thing a lot while it's operating, and there are going to be 4 of them, and they'll be operating probably 24/7. I also wanted it to be fully enclosed so that Tuco and I and curious guests don't stick our fingers in this thing and get maimed on the moving cords and gears. So there are a lot of ways to go about that, and I might still end up vacuum forming the enclosure, but it's easier if I can just design it to be something that I can 3D print without much material. So, like, you know, for example, this was a previous enclosure design, and it looks big, right? But it's a completely tractable 3D print. Like, it's a long print, but it's like under a day, which I consider completely doable. I mean, and I could probably still have made this a lot thinner than I did. I was just trying to get a little bit of structural support out of this middle thing, as you might have noticed. But yeah, without that, you can 3D print shells much thinner and have an aesthetic cover, basically. The concern about, the reason I would have vacuum formed it actually was more to do with making it transparent than actually saving print time, because vacuum forming would probably take more time than printing it. So yeah, but if you didn't really care as much about the noise, you're more willing to use a louder bearing solution, or you just put money into large diameter nice bearings, and that's fine too, if you want to do that. And then if you either were fine with making an enclosure and frame out of a larger material, like, you know, make this whole part out of something that isn't 3D printed, you know, make the outer channel here out of bent and cut metal, make it with 3D printed joints, and then you know, threaded rods as structural members in the other direction too. Like, there are a lot of ways you could design this to use less 3D printing time and to require a 3D printer that's less big. I just designed this for what I had. And that was, you know, it seemed easiest to make something that required relatively few off-the-shelf parts, but parts that I could get a lot of utility out of, like these bearings and threaded rods, and then just to solve most of the other problems with the 3D printer, because that's pretty expedient for me. But there are a lot of other ways you can design this depending on what's handy. Yeah, I think some of these other spools have the same thing. Like this one, it isn't quite as big, but you could totally make a nice coupler for this. That's probably how they wind these. In fact, I have a thingy, well, from Thingiverse, which makes it a thingy by definition. I mean, people have thought about this already. I don't have a URL for this one handy, but you can probably find it if you search for like spool winder drill chuck adapter, as that's what this does. And these are common enough that, you know, people are designing parts that fit onto it already. Do any of these fit then? Does it fit this one? Not really. How about this way? No. Yeah, okay, so it doesn't fit these spools at all. Does it fit? No. Does it fit these? Well, yeah, it fits these really well. So this must be a type that a lot of people use. I don't remember this being such a specific design, but I guess I only have one spool type here that it works with. But then you put that on there, and then you can just grip onto this with a drill chuck and wind. So this is nice. I would use this to wind a filament. For if you wanted to just try to turn this into a winch bot, like, okay, minimum viable winch bot. Let's say you just want to take this 3D printable single piece, or single vitamin, I guess. I guess it has 2 bolts, so like very low vitamin device that you can just print, add a couple of really simple, cheap parts that most people will have in abundance, or at least be able to walk to the hardware store and get. And then you've got this, and you can drive it, but all of that load is now on the drill's bearings. So maybe that's fine. Maybe you can just get a beefy drill and that'll work. But that's going to start to be a limitation. But yeah, I could totally see a different version of this project, maybe where you just chuck this into a drill, modify the drill's control circuitry, so you're driving the MOSFET now. Maybe you give it an H-bridge. Drills usually have mechanical reversing instead of electrical reversing, whereas you'd want electrical. You'd have to make sure the drill, the gear train is happy running in reverse, but that's probably fine. And then for, you'd want some feedback, but you could really just like paint encoder stripes on here and then just like point a reflectance sensor at that. So that would totally be an option. It's just now you have this thing that's actually pretty big and hard to put a box around. So I was kind of thinking ahead to like, well, I could do that, but I wouldn't want 4 of those in my living space all the time. So I was trying to think ahead to making something that I'd actually want to be around. And that's how we got here. That's how this thing got complicated. Oh, product design. Except, I mean, I don't know. Some people have asked, like, oh, are you going to make this, like, something, like, are you going to sell that, basically? I don't know. I mean, I'm certainly interested in making it something other people can apply. And maybe there's some place for me to kind of help out in that process. But I'm certainly not doing it because of that. I want to have a more internet-connected experience, and I think that would be fun for all of us. So anyway, now we're back to these. And this is more what I actually was kind of aiming to get into here. Oh, I'm just covered in spools. There's some little spools also for the wire I was using. Those look even less suitable than the printer spools, though. Oh, and this one just looks terrible by comparison. This was the previous revision of the design. And a lot of the design elements are still here. I mean, this is basically the same coupling. I improved these little coupling teeth quite a bit so they can survive literally being hammered together, and it works out pretty nicely. Made the gear a lot taller since that was the weak link, it turned out. But I mean, I made the gear twice as high, so. And this one was the weak link, but still strong enough, so I think the twice as high one should be fine. Anyway, the warping. So the reason this is happening, I think it's mostly because of this large pool of plastic I'm laying down in the bottom of the model. And, I don't have a heated bed, so all of the adhesion, it's going to end up needing a lot more bed adhesion at the edges because you've got all of the force of the plastic from the rest of this disc pulling toward, pulling from the edges toward the center. And so all of that kind of helps it, kind of bow up. Like, this is really not focusing. Maybe I'll have to take over the wheel from the servo AF here. Alright, so is this one flat? This one's a lot more flat. It might be a little bit bowed, but let's get something more provably flat here. I got a pack of these little plates of glass that I think they were cut for making window displays or like retail displays. They have that kind of nice bevel, but they're also just a super convenient size to work with, and it's nice that they don't have sharp edges. This would be a lot more interesting with some liquid. Do I want to get out the fluorescein? Oh, cool. Sodium in chat dug up the Thingiverse link from the spool winder. Thank you. Oh, you might be able to see it best right at that angle. Anyway, it looks fine until right about where my thumb is. And then this area from the outside is just really arcing in. And it would probably be usable, but it's worth trying to avoid this, so... I mean, I'm keeping this piece maybe in case I get desperate, but I think we can do better. I think it's worth reprinting that. Because it makes the whole thing kind of wobbly and misshapen as it spins, and it also affects the surface finish of all the stuff that gets printed over the warped area. So, let's try... I think my usual strategy for this is to do kind of a thermal relief, where, because the issue is you have this whole thing is very hot and it's all contracting, and all of that contracting force from this whole circle of hot plastic is all pulling against the edges. I want to break that connection between the edge and all of that contracting plastic so that the bit of edge that isn't being pulled so hard by that can really hold down better. That's kind of the strategy that the brim uses, where you print a very thin layer of plastic at the edge that kind of extends the contact area a bit. But that wasn't enough for this amount of contraction. So, yeah, and I mean, part of the problem here is even if I stuck these in a lathe to make them flat, as Vince is suggesting, I would be losing a lot of the material that I want, because the warp is actually a significant... Like, the amount that this is warping is about the same as the thickness of the material at the edge here. So, not so great. And this isn't solid all the way through. This is solid in the middle, about the same amount that it's solid out here, but then it's just infill, so I wouldn't really be doing myself a favor. Anyway, let's see if we can resolve this in software. Of course, all software requires input devices, but it doesn't really matter what input devices. I mean, like, I guess I was thinking that making software requires input devices. I guess if the software is making itself, then that's the exception. That doesn't happen, that's just a fairy tale. Okay. Do we need any CAD cam adjustments over there? Alright. Yeah, I guess machinists have a different strategy for this, but machinists probably don't have to worry about the infill in their aluminum bars, you know? These raw materials come out slightly weird, if you consider 3D print to be a raw material. Par-baked material. Algorithmically par-baked. Alright, so I don't really have anything to do here immediately. I just wanted to stop by the Flyer CAD because it was open and some of you might not have seen this recently. Let me turn off the hidden lines just to make this a little less busy. So, this is what we were seeing in person earlier with this load-bearing piece in the middle that the nylon cord ties down to, goes through this channel, and then a knot sits up here. Then the carbon fiber rods. This is a strain relief for the cord that goes up to the ceiling. So this is kind of a squishy NinjaFlex piece, and then a hard plastic outer piece that actually does the squishing. Then we have the microcontroller board. This is one of those same TI Tiva boards, using it for its Ethernet, as always. And then the IMU. I think I ended up going with the BNO 055. I was trying that one and one of the InventSense modules, but ended up going with this one. Has a magnetometer and built-in motion fusion algorithm, which is handy in this case. since I don't really feel like bothering with running that on this micro, and I really don't feel like bothering running it on the central controller after sending all of the relevant data over the network. So yeah, having this just spit out a bunch of useful metrics related to the orientation of this device, it's pretty nice. It gives you angle and separates out the acceleration due to gravity and the acceleration due to motion. This is on a weird little mount. All of this is printed and ready to go, and this is the Parallax X-band motion sensor module, which is also kind of something I threw in there kind of for fun. I don't really know how useful it is, but it does, like, I wired it up to a pulse counter on the microcontroller, so it'll take averages over short periods of time of how fast the pulses are coming in to get an idea of how much stuff is moving around the robot. So it can tell if people sneak up on it, basically. I think that's the use case. I don't know how useful it's going to be when the robot itself is moving, but when the robot, when it's just sitting on the table, I already know it actually works pretty well, so that's why it's still on the table. And then this little thing is the mounting bracket where the power comes in. This XT60 connector is way overkill, but I'm using it mainly for its mechanical prowess and because I had a bunch of them. And then I have several of these little, they say Daytel, but I think now they're made and sold by, the company that makes Murata. Yeah, Murata makes these now. Or you can find them on DigiKey, and that's who it says makes them. And they go from the 12 volts coming in on the leash to several different current-limited 5-volt supplies. So I'm going to probably have one of these for the sensors, one of them for the microcontroller, and 2 for the LEDs. And then we have some LEDs these are mostly for communicating with the humans that this is sharing the space with. And then this is my mock-up for the camera that we've been working on, the one with the gimbal. So just a quick tour of this robot. Looking forward to assembling this. If you want to be sure to catch that, subscribe to the streams. I'll be doing this assembly while waiting for the winchbot prints, probably. I've got most of the parts ready to go. I've just been saving it so that I can do it when I'm otherwise waiting on stuff. Alright, let's go to the winches. All of this stuff is in Git, by the way. It's not necessarily in Git in real time because I've been doing this stuff in Fusion 360 in their cloud storage, but when I have a significant rev of the design, at least I've been trying to commit them to Git. So yeah, GitHub, and then if you could just go to the Tuco Flyer organization, you can find everything for this project so far. So there's the mechanical design for the winches, for the Flyer robot. This is the central control software, which is just barely getting started, but this is the thing that I've been working on in Rust. This is the firmware for the actual TI microcontroller boards, which is mostly done, but still needs some algorithms for the motion control baked into it. And this is the chatbot interface that connects this to Twitch that Marx has been working on. So that is our humble organization so far. Certainly let me know if you want to work on any of this, and you can be added. And you'll find the files. I won't go through and bore you with the directory structure. Let's go to the winch. This is what I actually want to edit. Loading the winch. Oh yeah. Loading the winch. Okay. So there are a couple of different forks in this path here. This is a pretty good representation of the parts that I currently have on the desk right now. It's not that you could tell by looking at the desk or the monitor, but and so there are a few changes to make. There's modifying these spool pieces to be easier to print, which I think is going to be the first thing to do because I want to get these printing. There's modifying this center piece to have a recess for the knot, which might be the next thing I can do, because then I can start that one printing on the little printer, and then the robots will be busy for a while. And then there's some small things to do which involve each of the two printers. I wanted to tweak the shape of some of these rollers, well, all of the rollers, I think. These rollers bind a little bit, so I think I wanted to try just basically giving them more clearance around the bearings, but specifically changing the way that the bearing seats into this tube and having it be constrained a little bit less, so not constraining it at all with the outer tube, only with the inner tube. What else? This roller, the inner diameter is a little bit too large, so it just kind of wobbles around instead of actually rolling, so that needs a small tweak. And then I need to design these two new pieces that go on the top and bottom of this. So up here, I want a piece, you can see I've already got the fasteners lined up for it. I want a piece that supports these two rollers and this encoder and attaches here. I might end up also wanting that piece to act as an anchor for the side panels that act to enclose this whole thing. And so I haven't designed the side panels. I'm putting that off because I want to design that pretty much last, but I'm thinking about leaving anchors for them to attach to at least. And so up here I could have a piece that prints like along this axis, so say the print bed was maybe in the same plane as the front of the encoder perhaps, and then it prints up. I have holes for all these anchors, and then perhaps I also leave some room for, maybe up here in this area and then down here in the corresponding area down here. So like above where these rollers are, I leave room for pillars to come down to anchor the side pieces too. So that's something I might want to do. Down here, there's also a pretty obvious way to do that, I think, where I have a bracket that attaches to these holes that I've left. And then here I actually think I've got the opportunity to, and maybe I print it with the print bed in this plane. Maybe I go out and then perhaps down or up, either way, maybe both. Well, I should pick one to keep that planar, but going out and then one direction to basically make something that I think could double as an electronics mount and a mount for the outer shell. And so again, I want to push off the outer shell design until I get that far, because A, if I have to backtrack, I don't want to have to redo that work. B, I want to design the outer shell after I know exactly what it's enclosing, so I want to be able to push that off. But I can still design something that leaves an attachment point or two or three for that, and gives me space for the electronics, because down here it's starting to look like a good place for the microcontroller. If I don't mind having it sprayed with lube from the gears, maybe I have this act as a lube shield for the microcontroller. Or maybe it doesn't matter, because I'm sure this stuff is a good insulator. Alright. And then the shell also might have an interesting interaction with the wall mounting bracket, since the shell has to not be load-bearing, and this back surface is load-bearing. This back surface and the thread here are how this interfaces to the back bracket. So I might have to design how this and the bracket mate, and then figure out how the shell avoids that but still forms a clean boundary between this and the back. So just more questions where it's an intersection of, how do I make this work? How do I make it work reliably? How do I make something that I actually want in my space? And, there's certainly something to be said for just skipping those and just designing something that works. But I know I could do that. That isn't really interesting to me. I want to design something that I like and that I think will be something that I can keep in my space for a long time. Yeah, I guess that other way of doing things is like sprinting to an end goal, like when you're in kind of that startup mentality. It isn't like building furniture that I want to have for a while. Anyway, let's start with the spool. So I could probably make this pretty simple. I think I can just make a sketch in the same plane as the spool, rotate around a feature that cuts out the pieces that I want. Just have one thing that goes through both pieces here. So just to keep this fairly decoupled, I'm going to try putting it on this world plane down here, whichever one this was. XY, great. Those are some solid axes to use. Then we can project. I'm just going to project one of these interior surfaces, doesn't really matter. And I'm going to delete these because I don't want them. I don't want dependencies that are just going to break. And now I'm going to turn stuff off so that I can just edit this sketch the way I want. Yeah, okay, so now I've just got the sketch. So I'm going to make this construction geometry. One thing I want to decide is how much of this do I want to act as kind of my really beefed up brim. So how much of this is going to, like, its job is going to be to stick down to the bed really well and not necessarily be super hot and have a lot of contraction forces of its own. So I'm going to, like, guess maybe 5 millimeters, maybe 4 millimeters. Let's see how that looks. And we might use that as a mirroring line eventually. I'm thinking that these want to be like little arc-shaped cutouts, basically, so that all the plastic in here can shrink, but then you'll still have, I guess I probably want these to be, well, I don't know if this is the optimal shape, but the shape that comes to mind for this purpose is something like 2 circles. Connect these with lines, figure out a scale that makes sense, something like that. Making these tangent. And exhale. All right. That had an unintended consequence. It snapped to be tangent to the wrong thing. Well, the thing that I did not want it to be tangent to. Now, which of these constraints is the one that I need to delete to fix this? Or do I need to just undo this and fix it gradually some other way? Or maybe I did delete that constraint. This is the one that I was trying to delete. Anyway, I can also probably fix this if I do it gradually. No? Okay, well, if I just delete that, am I free to move this now? Why? Oh, there we go. I just have to drag it by a different part of itself. Great. Alright, solver. That was not as helpful as it could have been. I was thinking something like that. What does my middle sort of keep out area look like? This is the area of the spool that is angled. There we go. Let's project that point. Just that. Yeah, there it is. And let's go back into the safety of planar mode. Alright. Not to be tilting myself from this haven of XY. I was thinking about using that as a reference distance, but I think I'm going to avoid that. Let's just use this. So I was going to make another circle. This is like the edge of the support for the gear mechanism, so I don't really want to cut in beyond that. And in fact, I kind of want to keep my cuts some distance from that. But millimeter is actually fine. I think that'll be enough. Because this cut is very small at this end. And then can I just set these tangent? Yeah. Okay, so this will be solid at the edges, and then I'll have these cutouts. I mean, I think I want to break this up because as it is here, this is going to impact the structural stability, I think, more than I want. Maybe I increase this a bit just for structuralness. It also snapped to the unintended side. Maybe that's fine. I'm still gonna fix it. I wonder if I really only need this arc right here. Thinking, I wonder if that's enough. Then I can leave a lot of the material inside this. Like, what if I kind of ignore that end for now and make a vertical line? And then set some kind of distance there. And then some offsets maybe. Let's just do this. Nobody's watching. Oh, can I not? Let's try not chaining. Okay, maybe this needs to be multiple offsets. Maybe I need to trim it first. Cut. Yeah. I mean, the interior part of that just serves no structural purpose unless I connect it, and then I worry about it just making the problem worse. Unless I just connect it with kind of a thin bridge so that it can... Man, there's probably somebody who's studied this for years who knows exactly what to do. Maybe I just want this to be significantly farther that way. Some of this might work. Really? You can't make that tangent to all of these? Well, I can do that without... I was just going to make those rounded, but I can just do that with fillets. I can just do that with fillets. Famous last words of any CAD software user. Let's see what this looks like. Maybe I want this whole diameter to be bigger. Let's leave that, but I think I want to edit it. Oh, it is warm in here, and Tuco seems to be into that. The solver's just like, no, just don't even. You know what? Two can play at this game. Alright, so we have that whole thing. I kind of wanted that center line still. Now what do you say? Okay, maybe I just want a new circle after all. I want a new circle. One that won't something something. I never really listened to the original version of that song, but, you know, Weird Al. Anyone else like Weird Al? Everyone unsubscribes. Yeah, it was a while ago. Honest. Now I made a Pac-Man. Quack. Yeah, exactly. I guess I seem to have attached those. That's fine. That's a fine place for those to hang out. I'm not complaining. I kind of wanted something I could use. I don't think I can just set a distance between two circles. Is that... See, I've done that in the past, and it set the distance to the distance between the center locations. Maybe this is a special case when it knows they're concentric. Okay. I'll buy that. Can I make this something much bigger now? Oh, I mean, this is probably going to work, but it's probably going to be less optimal than it could be, but I don't really know exactly what, like, where the stress is concentrating the most. And then it's balance between, like, well, where is the stress concentrating, and then what structural strength am I giving up by removing, you know, by relieving that stress during printing. And the answer to most of this is just, I don't really even know how to think about that problem yet. Imagining the plastic contracting that direction, and then this is probably going to produce some kind of weird shear force right at this edge. So this is definitely going to need to be rounded. And then there's going to be kind of a web in between these that hold this part of the print down. I think I want this to be wider. Since all of this is going to be full of brim, which will also be holding it down. Whoa, how do I even geometry? Okay. Sometimes I forget which side's the front and which side's the back. You know, with the space mouse. You perverts. Now I'm just thinking about the angle here. I think I want it to be pretty steep, but maybe not 180 degrees. Whoa, that's not an angle. Why is that not an angle? Oh, because that's not a line. Okay, fair enough. Fair enough. Let's update this extrude. Yeah, it doesn't know what to profile. It's fine. Here's what you're looking for. Don't worry. Fillet. It's not the best way to do it, probably, but whatever. Look at them circles. That's exactly it. Okay. There's still a lot of material in here, which is where most of the force is going to be. And then this little tab is still actually going to be pretty strong. And then the cord running against there is going to have both that and this supporting it still. I think we're going to be fine. And now I just need to create many of those. So for that, I'm going to take these two features and make copies using pattern. It doesn't help to select them before entering the pattern tool for some reason. And then I can select both of those. This is mentioning with an extruding a hole, extent all. Does that only work for holes? I feel like I usually look for that, but I don't use the hole feature as much as I should. I usually just make everything an extrude. Okay, so it's not actually calculating these in real time, but it's showing here's one, and I can adjust how many of these there are. What does 9 look like? Is that too many? We can adjust that easily. That looks really weird. It's like it's smiling. It's kind of floral, actually, but it's kind of nice. So the goal with this is that this helps. Maybe I need more material removed. I don't know. I mean, mostly this is so that I get this exterior hopefully holding the bulk of this down and keeping it from warping so much. Alright, well let's think about that. Maybe this is fine. Maybe there's a better way to do it. But it's probably going to get printed. I'm probably going to try this out. But first, let's edit this centerpiece and make a new version of that, and then if we haven't come up with a new way to do this by then I'll just print this and see how it works. So this piece, it's constructed kind of strangely. Would have been easier. Well, let's get a better look at this first. Show you what we're up against. So this is what gets hammered into the gear portion. course, this is the part that always ends up warping, needs some thermal relief. This is the part that's the same. And then this pattern is so that you can just hammer it onto the top of this centerpiece. And in the center, this fits around some of that same 8mm threaded rod. And there's room for a cord to pass through. So I want to edit this so that there's a larger passageway for the knot to sit in. So the knot actually ends up sitting maybe halfway down here. And the way this is built, that is a little bit weird, but I think we can just do it. I think we can barrel ahead with this crazy contraption. So we might have to backtrack on the fillets, at least. So if I select this, well, usually there's something here for finding the feature that created this, but I guess you can also look for the little hashed marks above the feature here. In that case, it tells you, look, it's this one. Let's make sure. Let's see, why was edit feature grayed out there? And then I tried again and it's fine. Anyway. So 2 edges, so it's only these 2. Cool, let's just remove this. Or we could just back up in time to before that and then fix it. But I think let's just remove it. So it's going to recalculate the stuff after that. Oh man, good cat. Very good cat. Haha. It's funny the way Nicholas is describing the Space Mouse. I never thought of it having anything to do with handedness. The hands that I use computer interfaces with have nothing to do with my dominant hand. They all have to do with which hand the interface is designed for. Left-handed mice are totally not a thing that works for me. I mean, you'll see me switch hands a lot with some tools, because I just do that, but I write with my left hand. Alright, so then this goes all the way through, and it has a tube around it that actually provides the support. And I think those were assembled separately. There's a couple of different strategies we could do here. We could actually backtrack and try to edit this assembly and change the parts that are being assembled so that one of them, instead of just being a straight through tube, has that bump that we want to contain the knot. The other thing we could do is just layer something on top, just like forge ahead, hack and slash, and the way I would do it with that is just by making another kind of Boolean piece that I could use to cut out a larger hole here, and then to union in the material we need. But let's go back a little bit and see if there's a better way we can do this. I guess if we're backtracking anyway, there's no reason I really needed to delete that fillet, so I'm going to undo that. So I just undid the fillet delete. Let's go pretty far before that though. So let's at least wind this back to the fillet. And then step backwards. What was this? Was that the whole thing? Oh, right. So this was a bit of a mess. We're seeing this in reverse order. Maybe this will make more sense if I start from the beginning. Where's the beginning as far as we're concerned? Is that this? Oh, that was making gears. We don't care about that. Okay, so that made the core. What was that starting from? So I had this sketch where it's really just, this is the middle of my spool. That's what I want. That's very, very simple. Okay, and then I extruded it. And then another sketch. I was drawing the top pattern on here, and this had to Oh, this is the pattern of ribs. So I was dividing this into an exterior that I wanted solid, an interior I wanted solid, and then these ribs. There's an entire tool that does this in a slightly more automated fashion, which I knew about, and I even kind of know how to use it. This is just the method that seemed easiest at the time. And so if we step through there, cut that out. Then I rounded that mostly to avoid stress concentrations, also to kind of make it a little easier to print. Then here I was designing that, so this maybe is something we want to look into. Why did I just press stop? And what did that do? I meant to click the thing right next to it. I think that told it to rebuild everything. Although I'm going to have to wait until it finishes whatever it's doing to load the tooltip that'll tell me what it just did. Oh, I guess it wasn't a stop button when I clicked it. Play. Okay. Cool. I didn't mean to do that, but whatever. I think it just rebuilt what I had. So that was cutting it out. Then making a tube. Okay, well let's... Can we cut out the knot hole right here? I think we want to do it right here. I mean, this is already pretty messy, but I think the cleanest thing to do is to do it before this edge cut thing. So we have this tube. I'm just going to kind of cut and weld a bigger tube into this. And there are various reference planes I could choose. The most correct thing to do would probably be to make something new around the middle here. I could also just use this, which is probably just as good, honestly. I don't know. So let's start here. And so the knot hole, it's fine if it's kind of oversized. I mean, the main limitation is as that becomes bigger, it starts to get really close to this edge, which might be a problem. Let's see how much space we have. So there we can project it. Close that. And this is, I think, basically how I sized this to begin with. You know, I might want this to be closer to the edge anyway. I changed my mind about this sketch. Let's delete this sketch. I'm going to go back to this original sketch. And let's turn off the bodies. So this is the bottom of the spool, the edge of the spool, and I was trying to leave some margin there. I wasn't setting the amount of margin, I was just saying leave about the same margin, and then setting the closest I wanted that to the center over here. So let's do something different. Instead of this imaginary line or this imaginary line, we don't actually need either of those. Instead, it'd be nice if I could set the distance between these instead of setting the outer, which I guess I can do. Cool, so that's the wall thickness, which seems right. Then we have another wall out here, which I can set the thickness of. And then this is just going to be the amount of space I have for my knot. I can measure a knot. somehow don't have the end of a piece. Oh, actually I do have some paracord with the end handy. Not that it is super necessary, but it's right here. It's even got some knots in it already. And I'm looking for what is the diameter of a hole that this knot would fit in pretty comfortably. I think 10 millimeters would be pretty nice. It'd be cushy. Let's see if 10 millimeters looks doable. Oh, maybe it does. Okay, and then the next thing is I want this to be basically as close to the outside and bottom as possible, but maybe I want to leave a little bit of room for structural goodness. So maybe I have yet another additional circle out here. And here, maybe I just set that to like 1 millimeter. Alright, and that's definitely a construction line. And this, I want to be tangent to both of these. Okay, the stuff right after this is probably going to need updating, but that's great, that's why we're here. I'm going to have to turn the bodies back on. Oh, did that somehow not? Sometimes it's surprisingly good at figuring out which profiles I still meant. I don't know why that's grayed out, like, about half the time I look for it. Yeah, so that's the first extrude. Cutting out the whole thing. And get it whole. And then... is that the exterior? Yeah, that all looks great. So... is that plane meaningful? Where did this plane come from? Why is this even? Did I just make that on... I mean, that wouldn't be the worst place for the knot, but it's also not the best place for it. Let's just kind of put it in the center. So, plane at angle. Yeah, plane at angle, my old friend. We meet again at 90 degrees. And yeah, I guess I'm gonna have to project the stuff that I got from that other sketch on here. So I'm gonna need to make a sketch right here. Then grab some stuff. So right here, I'm going to have to make a bit of an adapter so that I extrude something along the bottom that provides some thickness for the wall here. And that's actually going to be kind of load bearing at first, at least. That's where the knot's pulling against. And then just a similar tube like I built before. It's got the pieces I want. So, not the center. Let's make... I was thinking ahead a little bit to the steps this will involve. Let me just cut this first. Oh, it looks like we were already embedded in this edge, but just barely. I don't want to rely on that structurally, though. It looks like we already have the feature we need, but we kind of don't. So let's build that up by like 2 millimeters. I need to make sure to leave enough room for the knot to actually fit in here. So maybe I'll build this up in the opposite direction. And in fact, if I'm doing that, I can build it somewhat further out. The very bottom of this is going to be a bridge that the printer has to print, because this is all designed to print without supports. I could add support there and it wouldn't really matter. Oops, I did not mean to end that. It just means that some of these edges, like going straight across is easy, but this geometry is starting to look hard to print. So I might just end up needing supports for that. And then something like that. I could just do that. It's a lot more plastic, but maybe it's fine. Maybe that's the most printable thing. Alright, let's go with that for now. And then over here, similar deal, but much wider. And then trim. Alright, that's much wider. It's closer to the bottom. Did I really need to leave that whole millimeter? I mean, if I set that to 0, then the tube would be sitting on the bottom. Yeah, let's see what that looks like actually just on the bottom. That's the wrong sketch. Alright, how does that look? That's got a lot less space for the knot. I think I'm going to still want some spacing between this and the edge, but between this and the bottom seems fine. Because otherwise I just don't have I don't have really enough room for the knot, because this just hits the edge really too quickly. Sometimes when I click the little, it's a little bit off screen, but there's like a little navigation cube you can use to reset the view, and sometimes I click that and I end up on the opposite side of the paper from what I'm used to. There we are. So no more of that. In fact, here I think we could benefit from a little more distance. So 2 maybe? Seems better. And, oh, this fillet, does this need adjusting? It should. I think we lost an edge. I don't know why it's not giving me a warning. Hmm. All right, well, there's our 1mm fillet. It's tempting to add some curviness in here, although that's actually kind of counter to our goals right now. Having a nice sharp edge to catch the knot is actually really nice, and this is also easier to print. I hope I did that in the right direction. Is that actually the direction I want? This is for cord winding with the end from here, winding around this way. I think that matches. So this like, oh geez, am I doing this right? I think I'm doing this right. Yeah. I mean, I guess worst case I can mirror the part while I print it, because the rest of it's symmetric. Alright, let's build the rest of this up. To go. Gotta keep that on the cat, you know? Where did everything else go? It just turned off. Okay. So this is spinning counterclockwise from this orientation as it winds, pulling the cord right along here. That seems nice. Alright. So this is a new version of all of these pieces. Oh yeah, Nicholas points out there's some interesting extrude options. Yeah, for sure, extrude is really powerful in this program. You can extrude two other objects, and there are some really surprising ways that the edges can interact when you do that, so it's worth trying all the options sometimes. Just gonna bump the version number on all these parts and then re-export the STL files. Get the printers busy on them. I think this is fine. Well, we'll see if it works, but I guess what I'm saying is this is the best idea I've got right now for the thermal relief pattern on the spools. Alright, so exports. Alright, and then two different Kiras. Okay, so how do I need to deal with the print settings here? Can I just start with the print settings I used in the previous version? I think I really want this to be in expert mode first. Spool drive side 3 or 2. The one I'm making is 3. The one I'm loading the settings from is 2. Okay, so we've got brim, 5mm infill. Here we go, 1.6mm bottom and top thickness, 1.6mm shell thickness. That's where I'm getting the strength from. And still loading the infill. There we go, so there's the brim, there's the edge of the spool, which will also kind of hopefully help to hold this whole thing down. You can see how this, so like around the very edges here, all of this plastic, this whole fan out is helping to hold this area down. And then you can imagine this kind of separates the spool into areas that I'm holding down, and then areas that I'm kind of letting absorb some of the thermal stresses. So I'm hoping this works out. All right, save that. I'm gonna do the other, slice the other half while I have these settings handy. It's pretty simple. Same deal, but without the gear. All right, and then the other piece I was going to do on my little Delta printer, which I've got set up in a different version of Cura here. I don't have to have that whole settings panel off the screen. Nice try, but completely upside down. Maybe I should turn on support material for this one. I guess support's enabled, it just didn't need any last time I printed this. Or maybe I didn't have it turned on then. This is not from those settings. Can I load my old settings this time too? Don't know where that corresponding option is to load the profile from the G-code. Well, the settings I had been using were pretty good though, so I think we can just start with that. So I've been modifying some of this. That's right, I was printing gears with this before, so I was using super thick walls. This whole thing is designed to be printed pretty much solid though too. Like, it's designed to have its own sparseness, but this whole piece is designed to be solid without any slicer infill. So maybe my settings here are already just about right for that. Let's see what it looks like. That looks fine. Yeah, see, that's the pattern I want. And then we've got support. I think we can do this without the support material. I think I was, like, the hole doesn't need to be perfect. It's just to retain some nylon. It needs to be strong, but That's just going to be annoying. Let's try this without support. I think that's what I did last time and it worked out nicely. I think it's still loading. Here we go. That looks like it's gonna work. All right. All right, so let's get these printing. First, I should go grab the SD card out of this printer and we can sneakernet that file over. Upload the rest. Plugged in. Look at that, it even opened. I kind of wanted the other window I had open here too. Alright, so that goes on here. I think all of these parts are old versions, so I'm just going to delete these so that they aren't distracting. So spool core 3. That's a big file for this printer. How long was the time estimate? 5 hours? Alright. I mean, this is, like, this whole spool is fairly load-bearing, so I guess that makes sense. This is maybe overkill, but I'm pretty happy with that. I don't think this is actually going to take 5 hours. That printer, I think, is faster than this is estimating. Oh, I guess I could also just click this and save to removable drive, and it would accomplish the same thing. Eject. Cool. Well, let's upload the other files to the Type A printer, and then go get these all started. Oh, I could have done everything with 2 segments in the pipe primitive. You mean that whole center spool, or just the opening? I mean, I know the opening could have been simpler, but I mean, the reason it was complicated was because I didn't feel like redesigning the whole thing, and each individual thing I added to it was simpler than redesigning the whole thing. But if you're saying the whole thing could be done with just 2 segments and a pipe primitive, I'm all ears. I think I can only upload 1 file at a time. Spool idler side, driver side. All right, let's have the mobile camera here. Oh, okay, the opening. Oh, just the ribs. Yeah, I'm sure there were better ways to do the ribs. Getting us a mobile camera so that you can join me in the printer closet. Whoops. I am trying to unrotate, not take photos. Great. So let's get this started. Hey, God. It's possible he might want to join us. As you can probably see, the Delta printer is not quite warm and my phone is low on battery. So that's the way things are. But here we are. I think the Delta, like, I was watching the bigger Type A printer carefully because it often needs bed leveling adjustments, whereas the little printer, just because it's a lot more compact and more structurally, you know, rigid, I think it's pretty good at staying in alignment. So I'm not as worried about it, but it still has some heating up to do. All right. Oh, are you asking about why the printer was in the closet? Yeah, mostly for the noise. I mostly print PLA, which doesn't really give off much in the way of nasty fumes, and this place is pretty drafty, so I wasn't really worried about the ventilation. But the closet is mostly to keep down the noise so I can have long prints going all the time without it keeping me up at night. You can usually hear the printer when something is going wrong. Not always, but a lot of problems actually make the printer a little louder, so it's a nice amount of distance to have. The noise of the printer is nice. I go in there and just listen to it sometimes, although I have to be careful about that because if I go in, I'm like, I have to close the door and keep the warm air in. I don't want drafts of air messing up my prints. Alright, so that was our modifications to the spool for today. Adding these relief holes, which might help with printing, and modifying the center here. And I want to print more of these. Printing another one of these bottom pieces is pretty low priority, since really the only thing I get out of that is I get to know if the design works. So I'll use this if I need to make another one of these, but printing this top piece is nice. Excuse me. Printing the top piece is nice because that both validates my design to see whether it's more printable than the last one, and it lets me test my new center, because I think I'm going to need a new top piece to test the new center. I don't think they're going to come apart after being hammered together. Oh, PLA. Well, Michaela's saying PLA likes cold air. I don't know if that's true. Having your printer in a drafty spot is actually really, really bad in my experience. It can be good to blow the air at the PLA as it's printing, but in a pretty controlled way, and usually not for the first few layers of the print in my experience. Maybe it matters less if you have a really nice heated bed, but for my printer at least, drafts are just the worst thing. Oh, Robert is asking, wait, what is this piece used for? Why is there that strange hole through the center, without actually making it clear which piece they're talking about? I mean, the only hole down the center of anything here is this one, which is for a threaded rod, which is how this thing sits in the bearings. That's the axle, I guess you'd call it. And then if you're talking about this off-center hole, that's for the nylon cord to tie off into. Anyway, but I'm done with this piece for now. I think we're good. Let's turn some other stuff back on. Frame? What? This is not how my document is supposed to look. What is going on here? This is supposed to be the frame piece. There must have been some kind of failure in rebuilding this. Oh, look at all that. What happened here? So there might be a couple of warnings here that are just things that I don't think are actually problems, but I couldn't figure out how to get it to shut up about, and then some of these are probably actually problems based on what is happening. It's saying a compute failed. Is this the first of these failures? Is there something else terrible that's hiding? I don't think so. Okay, where is the compute failure? Can you show me? See, it just says something like that. Oh, what is going on here? Oh, this should be a lot wider. What is going on here? What was it like right before this sketch? I'm trying to determine if this is the beginning of the problem. So the reason we're hitting this now, I think, is because I accidentally hit that play button in the middle of the toolbar, this one that caused it to rebuild, and that exposed a bug that was previously hidden. And so now I'm being forced to deal with it. I think we were fine before this sketch, so let's go back in there. Try to fix that bad geometry. So this is supposed to be way over there. What is it? Oh, I tried dragging it, and that made the problem a little better. What is over here? Something. Can I just drag it all the way? I'm trying to drag it. Maybe not. It's like, I can't tell, is it just being really slow or is it actually broken? This is not vertical right now. What is it anchored against up here? It's probably easier to just delete whatever this is. I think both of those lines are supposed to be vertical. They're also probably not supposed to be the same line. I already printed these pieces. I don't want to accidentally change them from what I printed. I don't know that there's something I can easily undo that'll just prevent me from having to deal with this right now. Oh, can I... Huh, I can kind of push it that direction. It would be really great if I could remember what this was supposed to look like, though. So this is a sketch that depends on a projection of the spool, which is fine. Why does it depend on the parts that I changed? And I mean, I made the change after. Like this is still using the same version of the spool that I originally made it with. You can see it doesn't have the holes in it yet. Oh, I guess I changed that early on, didn't I? That might be the problem. Where would that have shown up? Oh, this is just such a mess. All the geometry from this is just kind of broken and laying around in pieces. It'd be nice if right here I could have access to my printed model for reference. I'm wondering if I can do that, if I can just go to right before that sketch and put my print in right here. Oh, I probably have to import it into the cloud first. It's really amazing how frustrating technology can be. Hard to see why we put up with it. I really don't like this importer. These are like 500 kilobytes. Can't do anything with those yet. So the idea behind this was supposed to be based on this perimeter of the whole spool, then offset. And now several of these lines are just broken and not attached anymore on that side. Whereas this side seems to be more fine. And I'm just trying to even understand the mess that it's created here. Some of the lines for the offset seem to be joined to lines from the frame. Oh, and why is it taking so long to import a 0.5 megabyte? This is really tempting to find some way to ignore this and move on since I've already got the STLs, but oh, that's so depressing. Is this making any progress? Is this CPU bound? I'm pretty sure their uploader is entirely in the cloud. I'm probably waiting in line with a bunch of other people to get a millisecond of somebody's CPU time. Yeah, the computer is idle. It's just waiting on the clown. surface finish. Okay. Ooh, nice job with smooth shading. Wow. Haven't you heard of weld angles? Like, it's common to render these models by smoothing the normals only when the angles are actually similar. That just looks gross. Anyway, it'll be fine as a dimension reference. Is this one also similarly alright? Ugh. Oh, I can make it flat shaded. That's better. Not lying to me, at least. Well, not in ways that I care about. Okay. Can I have both of these right now in this document? I don't really want them to be linked, because that's just one more thing to go wrong. And if I have any linked files, I can't export this. So, scale. Is this not in millimeters? Scale. Oh yeah, of course, the scale is wrong and you don't give me a scale tool. That's cool. Can I scale faces? I mean bodies, I can't scale bodies. Ah. Can we see the printer? It looks solid still with the brim filling in the little openings. Oh, a comment from Caleb in the chat who asks what's going on, if anybody wants to fill him in. Yeah, so well, the big picture project is I'm working on a kind of winch-operated camera robot that can hang out with my cat and stream some interactivity with him on the internet. And there are a lot of little sub-projects that's led to. This current project is building a winch, kind of a robotic winch that I can have 4 of, pulling this robot around. Wake up, camera. And so this is my winch prototype so far. We're in CAD making some modifications to it, and now I'm just dealing with Fusion 360 headaches. Made some changes to the spool to increase printability, and the next thing on the list is to make some brackets that attach up here and down here. But my model for this piece, which is already printed, has just exploded in Fusion, and I'm trying to put it back together. But yeah, this is frustrating. I might be hitting the limit for how much frustration I can deal with before dinner. So that might be a time to at least switch gears, if not end the stream. I just imported this STL as reference, and the scale is wrong. That's great. I just hit break link, and then the entire piece disappears, and then the UI just stops responding. I could also just design everything else in Rhino and stop using Fusion 360 entirely and just deal with all the exported files I have so far. I could probably actually do that. That might actually save time. Not quite sure. Can I scale this? A preview of the, wait, is it? I have to enable this in preferences? Oh, okay, that's probably not something I want yet. Can I scale it without having to do that? This is all move. It'd also be nice if it just let me specify the scale during import, but the import interface is basically you drag files in and then eventually it either gives you an error in the form of a PDF or it lets you open the document. It's really bad. Oh, geez, maybe I do have to use their experimental mesh editor. Maybe I don't want to. Maybe I just need to undo everything I've been doing just now and then try to redo the center of the spool without disturbing the history. How far do I have to back up to get that to work? I think I just have to take all of today's modifications out. Can I do that? Can I do that without just like clicking this a bunch of times? Well, I guess I can keep these, but oh, this is so depressing. I really don't want to have to undo all of that. No, I'm gonna redo and see if I can keep fixing this. Maybe I should take a break and get some dinner and think about how to proceed. This is a comically large import, isn't it? Oh, this is so much broken. I guess, yeah, fine. Let's have you know, Fusion, I couldn't imagine Fusion crashing that much more than it already does, so sure, let's try experimental mesh editing. How do I even find the preferences? They couldn't bother to have a menu bar. Is it way over there? Cool. Mesh. Oh, okay. So now I'm just not allowed to complain if this ever crashes. If it ever crashes, it's always the mesh workspace's fault. That's how this works. Can I edit it now? You know, I could have just done this in a separate program, but I don't even really know what scale this wants. So, measure. What reference points do I have here? I think this was supposed to be like 16 millimeters in diameter. Oh, do I have snap? What is that? This is not snapping to vertices. Okay. Mesh point. Yes, but that's not a point in the mesh. That's just a point on the surface defined by the mesh. Fine. Let's do this very approximately. Really? Okay, well I have a physical model right here. What is that actually supposed to be? I'm measuring off of my 3D print, 17 3/4. That'd be great if I had the real model here. Anyway, is there a scale tool even? Scale. Now I can just type in a scale factor. If only I knew what it should be. Was it in centimeters? Could that have been a thing? Could it just be a factor of 10? Does any of this line up? Oh, they don't have any kind of surface analysis or snapping or any of it. It's just like click anywhere. And is our scale right? Looks like it. I guess it was in millimeters and expecting it to be centimeters for some reason. Which is interesting that the default import and export for STL in the same program would have a different scale. And I mean, well, lining this up is just not going to be a thing, is it? I can get it close just so that I can see what's supposed to go where while I'm trying to fix the sketch. Yeah, except that's completely not in the right vertical location. This lines up according to the motor face right there. No. Ah! Okay, this is... Let's just leave it there. What does it take to edit this sketch? Like, I wanted to right-click on it to roll the history marker to it, but I can't right-click. Like, right-click does nothing. Okay. Oh, I have to finish the mesh. So cool to have all these modal interfaces. Alright, yeah, compute failed. Roll history marker. Okay, I've got kind of a reference now. It doesn't really line up and it's made of triangles, but... stay planar. I don't know what this line was supposed to be for. Where did this come from? Was this box even here before? Oh, this is really annoying. Do I even have a step file from that part? Alright, well, I think I'm going to take a break from this and get a bite to eat, and then think about how to deal with this. It's still pretty early here, so maybe I'll have it in me to do another stream. The streaming versus not streaming for me a lot of times is based on how much energy I have for being around other people, even if it's such as it is through the internet. I might have more of that, but there's also, I could put more energy into video editing, which, as much as I like the streams, the edited videos are things that I think more people can enjoy, so I like being able to put time into the editing too. So, yeah, I think I need to take a step back from this and think about it again. I mean, there's various kind of brute force things that I could do to salvage the work so far without having to go redo a bunch of stuff just to appease Fusion. Like, I could probably export the center piece that I have right now as a step file, then unwind my undo history a whole bunch, then export the frame as a step file, export everything else that's not broken, then create a completely new Autodesk file and try to recombine stuff, and then make all the stuff that I haven't started yet. This was partly the result of me, previously I tried making a bunch of separate files in Autodesk Fusion 360 that all linked with each other, and that turned out to be a huge maintenance nightmare. So this one is just completely monolithic. It's just one file with everything. And now I'm discovering how that feels. So I don't really know what's going to end up being good. I mean, I'm probably not going to put a lot of time into using this program more. Since I'm probably going to be doing other CAD using different tools if I can, I'm mostly just thinking well, how do I salvage this design so that I can finish what I'm doing here? And the easiest way to do that might just be tricks with my undo buffer here and exporting files, as annoying as that is. I'll have to check the files that I have in GitHub because they might be new enough to have the frame piece completed, but I mean, I'm not entirely sure about that. And then in that case, I might have to go undo to get my frame piece back because this is a mess. I don't know how I'm going to fix this. This sketch is just completely lopsided, and I don't even know which lines are supposed to go to where. So, and then this is probably the root cause of a bunch of these problems down the line, but it might not be, which is also scary. So that's exhausting. Oh yeah, sodium sensor might be a step file in there too. Mikkel is asking if I'd try out Onshape. I mean, I'll try it maybe. I'm not super excited about going further in the direction of centralized cloud software because that's a lot of what I don't like about Fusion 360. So maybe it's I'll have to evaluate it to see if maybe it's just more pleasant to use, but it definitely doesn't seem like the kind of thing that I want to put time into supporting if I can avoid it. So, I mean, I want to spend some more time seeing if I can make FreeCAD or SolveSpace work for my projects. But yeah, it's all super frustrating. Not really quite sure what to do next. Oh, cool. Sodium says the frame piece in GitHub looks complete, or at least complete-ish. Let's take a look at what I've got in not Fusion 360. So file types. These that are showing up as Rhino models are actually, oh, well, these are actually Rhino models. These are 3DMs. But then step files are also going to open with Rhino. So this is the recent most winch bot. I'm going to, while I'm here, export a step file from here that at least notes that I have a working spool and a broken frame. Do I care about rolling this forward at all? I think I do. So going forward over a bunch of broken stuff. And no more planar. Yeah, maybe just exporting is kind of the thing. Yeah, maybe in Rhino, I'll take a look at the last step file I have and compare it just like right side by side with the STL file, and if they look like I don't see any features that are missing, then I can just run with that. What is happening on my screen right now? So Rhino is open. The black screen is coming from Fusion 360, which is trying to export, I think. Okay, well, let's just leave it alone for a while. Make some screen space. This top, I don't need this text command line to be so long. Am I mouse having problems now? Scroll wheel. The menus in Rhino are not working, and the scroll wheel is not working, but the space mouse is. Is this related to this? What's going on here? Will that change once I answer this modal? Is that what's going on? Let's hyphenate this maybe. Working, spool, broken, everything else. This is clearly a reasonable file name. Okay, so Fusion 360. Yeah, what is wrong with Rhino? Oh, there was a dialog box that I didn't see, modal dialogues. Man. It probably thought my screen was still bigger and was putting it where it thought the middle was. This also sometimes just freezes the UI during imports. Yeah. Okay, now we can do some navigation. Let's turn on ghosted mode. Is it loading shaders or something? Okay. Wow, something in here is rendering slowly. Is that the gears, maybe? Is it better if I... So wireframe is fast. Shaded is... It might be having trouble with all those visible lines in the gear. That's embarrassing. Oh man. That's not an improvement. No, maybe it's just slow. This... Huh, okay. That's frustrating. Maybe FreeCAD's not the only CAD package that has trouble rendering this whole thing. Anyway, this piece looks right. Like, it's the right width. It has these features. I think these nut holes and the width change were the last two things I did to this. Top looks fine. Oh, this is just like one really complicated object right now, but I can break it apart pretty easily. So, oh yeah, that's nice and smooth. So let's side by side compare this with the STL files then, on a different layer. Oh, I thought that was going to use my color, but it's taking the color from the object, which is fine. But that's on layer 1 now. And let's make a new layer. And import. I guess I can import one at a time. Oh, that wasn't actually the piece I wanted, but it's really handy that these all use a consistent coordinate system, at least. Oh. This is frame, right? Not spool, frame. Oh, that's cool. That, if the Z fighting is any indication, is the right version. This is drive side. Oh, I got the wrong one again. Frame drive side. There we go. Alright, well maybe I can move ahead and do some of this in Rhino. Maybe that wouldn't be terrible. What I'll probably want to do is carve up the design into separate step files to some extent. I don't know how much I'm going to worry about that, but at least it would be nice to have one file that has both a working frame and a working spool, so maybe I'll try to make that happen. I'm just seeing the downsides to not having one file that has all of this integrated, but... I mean, it's easy enough to import all the parts and then add joints in whichever CAD package I want, but just deciding whether or not I want to make the plunge into actually starting to create portions of this design in ways that absolutely can't be merged back in with the rest of it. Anyway, that sounds like something I should think about over a bowl of rice, maybe. These pieces seem alright. And we can show all the rest of the stuff here. This is the old version of the spool. Wow, this frame rate is really annoying. What can I do for that? Is there a particular object that's slow? Is it just the gears? It's not just the gears. Well, I'm going to have to give Fusion's rendering a bit more credit for being speedy. Didn't I realized the competition was going to have so much trouble in this model. Now I'm just looking like, okay, where's the polygon count? I don't know if it's polygons though, it might be edges that are actually the slow part. But I would have expected to find that out by setting it to rendered, which doesn't have edges. This is also slow. And I don't have these all set up as layers, so it's harder to turn off individual objects, but we can just hide them. So like these screw threads might be part of the problem. I don't know, man. Bearings. I mean, that would make it totally doable for modeling, but man, this is like the state of computer-aided design. I mean, I was used to this from electrical engineering, but it seems like in this field it's pretty similar, where like all of the tools are just so bad, and they're all just bad in different ways. Like, I really like Rhino, but I don't necessarily know if I would choose it first for this kind of design where there's just a lot of constraints and stuff. I might use Grasshopper plus Rhino, but then that's a little bit more off the beaten path. That's a little bit more like trying to make something big like this in OpenSCAD, which also might be an option, but so far my experiences with OpenSCAD have been mostly making smaller things, and then when I've made larger things in OpenSCAD, it's kind of made me wish I hadn't. And I could try Onshape, but I just don't want to get even more into the cloud with this. Anyway, enough rambling. I think it's time to wrap this stream up with some cat. I was just catching up with cat a little bit, but oh, nice. I missed the link earlier, but Sodium posted a link to the Autodesk browser with this part, I think. Yeah, the Autodesk browser is quite surprisingly good in the web, in HTML. I'm going to focus the cat cam. And yeah, I'm super used to the layers. Yeah, in Rhino, the main way that I would organize stuff is with layers. So it's been a bit of a transition using components for that in Fusion 360. Rhino has something else that's a little bit like components. If I remember right, they're called blocks. And you can have instances of them that refer to other geometry and like make lightweight copies and that kind of thing. But they're a little bit like if you had a component that only had bodies in it in Fusion, I think. Anyway, a lot of differences, a lot of things. Things are very different, but you can still do a lot of the similar things. Anyway, it'd be nice to do some more work with Rhino on stream. I'll have to think about how to resolve my current explosion in my Fusion 360 timeline, but if the answer to that turns out to be just screw it, do all the rest of the parts in whatever tool I feel like and don't worry about consistency, then if that's the case, then I'm just going to try to export as many things as I can as individual step files and then stop maintaining the Autodesk sources and then just make the individual parts in whatever tools work for that individual part. So maybe I'll do some of them in Rhino, maybe I'll do some of them in OpenSCAD or whatever. I've also used Blender for this kind of work before, which at the time I think I was putting up with a lot of slowness in its Boolean engine that I don't know if I'd have the patience for at this point now that I've seen some tools that are better at it, but maybe the Booleans have improved, so I could also give Blender another shot. But yeah, that's pretty much the state of things. Thanks so much for tuning in, And as always, thanks to everyone who supports the channel with ideas, with hardware, and especially with money, with the monthly Patreon dollars. Even just $1 a month is super helpful because, you know, having a lot of people who like the channel pitch in just a little bit is actually really nice. It's actually way better than just having a small group of people who have just like rabid amounts of support. You know, that's kind of nice too, but the large group of people that can each help a little bit is actually super nice, both for the kind of financial and emotional sustainability of things. So, thanks for tuning in, everyone. I will see you next time.